Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. So we want to find the frictional power needed to overcome the pumping from the bottom reservoir to the top reservoir. The shaft power is 21 kilowatts. The height is 46 meters. The volume flow rate is 0.04 meters cubed per second. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. So we're pumping a lake, and we're starting at the bottom reservoir of the lake up to the top reservoir. Okay. So Step 2, list all the given variables and find the unknown. So power of the pump in is 21 kilowatts, height is 46 meters, volume flow rate is 0.04 meters cubed per second, and we want to find the power from the friction. So that is using the formula in step 3. The power of friction is the power of the pump minus the mechanical power. So they give us the power of the pump, so we need to find the mechanical power. Step 4, find the mechanical power formula. So in this case, it will be density multiplied by volume flow rate multiplied by gravity multiplied by the elevation. So everything's given, so we're just going to plug and play. So since it's a lake, it's going to be fresh water. So 1000 kilograms per meter cubed multiplied by 0.04 meters cubed per second multiplied by 9.81 meters per second squared multiplied by 46 meters multiplied by the conversion unit to get it to kilowatts. So for your mechanical power, you'll get 18.050 kilowatts. Step 6, now we can backtrack and solve today's question. So we want to find the frictional power. So that is the pump minus the mechanical power. So 21 kilowatts minus 18.050 kilowatts. So 2.95 kilowatts of frictional power is required to overcome the friction in the pipe. So in an ideal system, you would only need 18.05 kilowatts. However, in reality, since there are losses, you need a greater power. So since there's frictional losses, you need 21 kilowatts. Now, if you were to make the pipes more streamlined, or just have a direct vertical pump, then you would require less energy. However, since they are using bends for the pump, you do have frictional losses. So that's what this paragraph is stating, and I'm just paraphrasing. Okay, disclaimers. The method is correct, however I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things just happen. You can do this by using snipping tool. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. Click on the icon in your taskbar. If it's not in your taskbar, go to your Windows search, type in snipping tool. Open up the program. Once you have it open, click on video option, click on new, left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button and snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish, hit the red square and snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends, because this is a made-up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.